What is data? Data, the plural of datum, are things we know of or the assumptions we make about the world around us. The assumptions and the known facts together form the basis of reasoning, projection, generalization, and inferencing. Data essentially is the record of the facts of the objects or the events happening in the world. In the business context, the objects could be the customers, the product, the competitors, and events could be the business transaction, consumer and competitor behavior, or the new policies or regulation, laws and the bylaws enacted by the government. So in the context of data analysis, we see everything as objects to help us understand the world around us. Let's take an example of an object. Object will have features or attributes. These features and attributes could be static or dynamic. And there are associated unique values of these features with the object, which help us uniquely identify an object. Let us say if you want to talk about a person, the name of the person, the age of the person, the blood group of the person, the email address of the person, the phone number, the income, the education. These are all the data associated with the features of one person. The features are also called as variables or attributes. Data characterizes the objects, and data can also be considered as observed values of the variables. Data can be classified in various categories based on different bases of classification. Some of the simpler bases could be the source of data. Is it a primary source or a secondary source? The basis of how the data originated, whether it was machine generated or human action generated, etc. There are two bases which are very relevant and important for studying data analysis. Is the basis of the scale of measurement. And the scale of qualitative and quantitative. So qualitative data is the one where we cannot perform mathematical operations on this data. Let us say name of the person. Or it could be the color preference of the person. Or it could be the address of the office of the competitor. There is no sense of order and no mathematical operations can be performed. There might be instances of numeric data in the qualitative format as well. For example, an employee ID, a unique identifier, it is numeric, but it is qualitative. On the other hand, quantitative data, we can perform mathematical operations. We can take average, we can take the sum, we can also look at other complex attributes like skewness and kurtosis. Basically, we can perform mathematical operations. Within the quantitative, we have two types of categories, discrete and continuous. This will become very important as we build the foundation for the distributions. Discrete are the ones which only assume integer values. For example, number of employees, number of children, number of people, number of items in the basket. Whereas on the other hand, continuous is the one which can assume any value on the real number line, like revenue, height, weight, distances, temperature, etc. This forms a very important basis for us to determine what statistical methods we can apply on this data. Similarly, we can categorize data on the basis of the scale of measurement, metric versus non-metric. Let's start with the non-metric. In non-metric, we have two categories. One, nominal, and other, ordinal. Nominal is a label of the data or label of the object, like name or a unique identifier. Whereas in case of ordinal, we have the sense of order besides just the label. Let us say rank. We understand that rank 1 and rank 2 are different, but we don't know how far apart are rank 1 and rank 2. They could be different significantly, or they could be almost similar. So we don't have that information or that intelligence available from this data, but we know the certain sense of order. On the other hand, in case of metric, we have two types again, interval scale data and the ratio scale data. From all practical purposes, the interval scale data and the ratio scale data are treated in the same fashion. But there is a very distinct fundamental difference. Interval scale data does not have an absolute zero. Also, interval scale data is invariant to addition of a constant. For example, 1, 2, 3, 4, 5 is same as 11, 12, 13, 14, 15. We have added a constant 10. The scale does not get altered. In case of ratio scale data, it is invariant to a multiplication by a constant. For example, 1, 2, 3, 4, 5 is same as 10, 20, 30, 40, 50. In case of ratio scale data, the ratios have some meaning. For example, when you say somebody is 20-year-old versus somebody is 40-year-old, you can say that the person who is 40-year-old is double the age of the person who is 20-year-old. In case of interval scale data, we cannot make any such statements. Also, interval scale data originates in psychometry. Typically, the customer rating scale, wherein they ask you how good you feel about a certain service that is rendered at a restaurant, at a hotel, at a restroom, and so on. There is no zero. The scale is 1, 2, 3, 4, 5. With this as a basis, now we can discuss about statistics.